Hello, my name is Zachary Miranda, and this is my video walkthrough for the Python final project. My goal with the final project was to make a Texas Hold'em video game. I was generally successful in achieving that with some trade-offs kind of in between, which I will go over once we get to them. The code was written and works in native Linux. I cannot guarantee it will work on a non-Linux operating system. So just take that into consideration when running it. Here we have the deck class. It incorporates that card class to represent a deck of cards, the typical 52, and then some actions associated with the deck. So uh, here you can see we can draw a card, which just pops a card off the list. We can shuffle with the random module. And then we can reset by calling a helper method for make cards. So effectively, what that does is it takes the the cross product of ranks and suits and creates 52 unique cards. And then here we have some dunder methods. One of them is to create the string representation of the deck, and then the other one is to return the length of the deck. Here is the player class. The player class is intended to represent just a typical Texas Hold'em player and the actions available to that player. Uh, it is a parent class to the human player class that we will show next after this. It has some key attributes that represent a typical player, an ID, the bank available to the player, and then if it is an AI player, the strategies it will implement. And then here we have a series of attributes that will be leveraged by the game to have the player play the game. The methods kind of represent the typical actions of the player. So bet and check both represent the process of betting and checking. The earn method here uh, adds money to the bank after they earn at the end of a round. And here, get action is kind of one of the key pieces of the strategy implementation. I would have loved to build a more complex solution here, representing knowledge of the community cards and probability of hand types and stuff like that. But the complexity and time limitations really kind of had me keep it at a simple implementation like this one here. Uh, it effectively it takes a series of actions based off of the strategy. It's the probability of how likely we are to commit one of those actions. And then if it is a money betting action, like a bet, we calculate how much the person is willing to bet based off of their tolerance, based off of the strategy. We then go ahead and set the action string, and we return the amount we're willing to bet. And here we have some helper methods. One is to set the action string, and then two more, which is will be used later in the game, and then two more around just kind of returning the clear, the action, and the bet amount to their normal values. This is the human player class. The human player class is a subclass of the player class. The intent of this method is to give the user some interactivity with the game. And this is done primarily through this get action method. Uh, the get action method is effectively a series of prompts and allows the user to input any action that they would like to do, whether that be bet, check, or fold. And then it sends that to the back end game logic. This is one area what I would have liked to kind of further expand and take it out of the terminal process and into the display, the Pygame display. Unfortunately, just due to time limitations, I was not able to make that happen. This is the hand classifier class. The intent of this class is to take a hand object and its associated cards
and determine what kind of poker hand it is. This is done through a series of methods that determine the attributes of the cards. So, for example, is flush here determines if their hand contains a flush. Is royal here determines if the cards consist of the royal rank, which is ace, king, queen, jack, 10. Is straight determines if there is any kind of straight within the cards. Is full house determines if there's a full house. Is two pair determines if there are two distinct pairs. And then is pair here determines if it contains a 4 of a kind, 3 of a kind, or a pair. What it then does is takes each of those attributes and then classifies the hand. So for example, here you can see if the hand is royal and is a flush, we give it the highest rated hand, which is the royal flush, right? If it's straight and a flush, we determine it as a straight flush, and so on and so forth. And then we return that to the game to determine the winner. Now, we have some helper methods here. One of them to make a series of data objects that are commonly used in the hand classification. One that maps the card rank to a discrete number. And then another one that returns the actual ranking of the hand tied to some point value. And then down here we have the property and setter method. So here we have the game round class. The game round class is intended to represent a typical game round of Texas Hold'em, and I would argue contains a majority of the game logic associated with Texas Hold'em. We first start up by setting up the round. So we shuffle the deck and take the blind bets from the players. We then have a series of methods here intended to deal cards to either the player or the community hand. The player gets 2 cards, and then through a series of betting rounds, more cards are dealt to the community hand. So between each dealing, there is a take bets action. So take bets action effectively determines what action a player is going to take and how it impacts the rest of the players. So here you can see we run a while loop, and while it's true, we determine who are active players. So if a player has enough money and hasn't folded, they are an active player. If there's only one player left, they are the winner. So we go ahead and determine them the winner. If we then go ahead and take what is the current maximum bet, every player must meet the maximum bet or they are out. So here is a series of logic. Every player has had to have acted, and every player needs to match the current maximum bet to be in the game. Once every player has done that, we go ahead and proceed on to the dealing the next card. And so here we start kind of a loop through each of the players. We determine if they folded. If they haven't folded, we go ahead and get their action. If it's a user, then they will get the action prompt from the human player class. If it is an AI, we will go ahead and just get their action based off of their strategy. We then go ahead and, based off of their action, determine how to update the maximum bet, their current action, and if they are an active player. And then once everything is finished, we go ahead and we clear the action string and go ahead and clear the bet amount. And then we update the game state dictionary to pass that to the display. On finishing the round of betting and upon finishing the round, we determine the winner and then we pay out the pot. So here are some of the helper methods we saw before. Shuffle the deck, take the blinds, deal the cards to the player or the community hand. We use that winner finder class to go ahead and determine the winner. And then we make a text representation of the winner and how much they won, pay out the pot, lets the winner earn the amount, And the game state dictionary is going to be the primary data that is going to be passed to the display to update the user on what's going on. The Texas Hold'em display class generates the display using Pygame for the user. This is done in a very simple way. Kind of like I said previously, I was not able to implement the user input in, but I wanted to go ahead and pass key information to the player through this class. It uses a couple of simple methods. Draw table just creates a green background, typically representing a poker table. Draw card is a helper method to draw the representation of a card. Just the typical rectangle of a card and then the text associated with that card. Render game state is one of the primary display outputs here. What that does is it takes that game state dictionary and parses the information and updates the display to show that information to the user. So you can see we can draw the community cards, we draw the player cards, and we draw the left opponent, the top opponent cards, and then the right opponent cards. And then we can also show the user the pot, so what the current amount of the pot is, how much they have in the bank, and then once a winner is selected, who won and how much did they win. We then have a run method here that allows the screen to update when a new game state is passed. So the dealer class acts as a bridge between the display and the game round logic. It also handles all of the between round tasks performed after a game round is finished. We start by first setting up the game, so we randomly seat the players, and we go ahead and give them an active hand instance, and then we also make sure that they have an active action string so they can participate in the game. We then go ahead and run the game, so we set a while loop here. As soon as there's only one player left between rounds, that player wins the game. If not, we then go ahead and circularly iterate through each player and give them a blind. We then go ahead and assign those blinds to the players, and we then go ahead and pass the players and those blind amounts to a game round. The way a game round is executed is with this advanced phase method here. The advanced phase method increments the round every time it's called. So you can see here it starts at a not started phase. It then goes ahead and sets up the round, and then it increments up to a round start. Then next time it's called, if it's round start, we deal the hand, and then increment up to a pre-flop. And then next time it's called, we go to a pre-flop, we take the bets, we then go to a flop, so on and so forth, until we hit an exit. And once the exit, we return nothing, a none. So then here, logically, we wrap it in a while loop, and as long as it's not exit, we keep incrementing the rounds. And then we pass the game state onto the display so the user can see the relevant game information. Once that's all done, we can pass, we go ahead and sleep for 5 seconds so the user can see the final screen and see the results. We then go ahead and handle the between round tasks. So we reset the player blinds, we go ahead and increment up the blinds, and then we take a series of steps to prepare for the next round. So we make the player hands, so we reset the hands, we reset the action string. If any player cannot meet the big blind bet, they are removed from the game. We then go ahead and reset the game state dictionary to be used again, and then we go ahead and make all players that had folded in the previous round active again. So I'm going to go ahead and demo the game real quick. You can see here we are in the project directory. I'm going to go ahead and run playgame.py. This will create the display and ask us what we would like to do. So we are first to bet here. We're going to go ahead and check. So we see each person checks, and then we go ahead and get dealt our community cards. There's a 5 pair there. We're going to go ahead and bet. And let's go ahead and bet $10. And so it looks like player 2 folded, player 3 calls. So we're going to go ahead and check again. We go ahead and see a 3 of a kind there. There's one more card left to be dealt, so let's run it. I don't like it, so I'm going to go ahead and fold. And so you can see that the final player, the winner was player 3 with a pot of 46.